Okay, folks, 10-2B, arithmetic sequences. So, second part of this time we're going to kind of look at sums and then end terms of arithmetic sequences. Just a couple different things that we didn't get to in 10-2A. So, first thing, let's talk about first difference. First difference is similar to your D value. It's all the sequence here. It's just found by subtracting each term from its successive term, just kind of like when we found our D value. Difference, but your first difference, if they're all the same, when we think about just investigating them a little bit, if they're all the same, then we can say that the sequence is arithmetic. And then the nth term can be modeled by a linear function, like a line, a graph would be a line, in this form. A sub n equals d sub n plus a sub 0. So it's just kind of a constant with a slope, so it would kind of be a linear line because that difference is always going to be the same, so it's going to be constant difference every time. A second difference. So second difference, if you can subtract consecutive first differences. So you've already had, say, these, you've already did that, you've already subtracted and found your first differences. Now if you subtract them again a second time, if those are constants, we might see another type of function that we can model. So like say if the second difference, if those are constant, then the nth term of the sequence can be modeled by a quadratic function. Okay, so subtracting the successive terms once, if they're constant, you can say, well, it's going to be linear. If you subtract them a second time, those differences, and you get constant, then you get the same amount every time, then you can say that it's going to be a quadratic form, and that would be in this form here, a sub n equals an squared plus bn plus c. You're quadratic, right? With you're kind of like the quadratic formula, very similar to those quadratic equations we've seen before. Okay, so here's an example here where we'll just kind of point out a few things. So in this second difference, so quadratic model for this sequence here. So you've got these terms, and we're saying that this nth term can be represented by a quadratic equation in this form. So what we're saying is that they've already done the second differences and they're already constant, so we know it's going to work for this equation here. All right, so if we substitute values into those equations, right, if we take 12 is our first term, right? It's right here. It's our first term. So if I put 12 on the left side of the equal sign, and then for my n's, I plug in 1 because it's the first term, I'm going to get a1 squared plus b1. Same thing if I do with 20, I'm going to get the second term here, but 20 goes on the outside. And then 30 is your third term. So if I do that, I'm going to get a3 squared plus b to the b3 plus c, n being 1, 2, 3, a sub n being these numbers here. So just get a look at the formula. A sub n goes on the left side there, and then you've got your n values that go here and here. Okay, when you simplify those, you end up with kind of these equations right here. Okay, and it's just simplifying, squaring them, multiplying, whatever. So you get those. Then you're going to have to solve a system of 3 equations, and when you do that, you end up getting an A, a B, and a C. When you solve it, solving it's probably the most difficult part. But once you get your A, B, and C values here, then you can fire those into our quadratic equation here, here, and here, or in this case, right here, and right here. So because we found our A, B, and C, we know that A is 1 here. I put my 5 in here for B, and I put my 6 right here for C. Okay, and then you can kind of see this equation here and what it would graph like in this model over here, figure 10.2.1. Okay, so that's a lot of explaining how it is. We'll kind of show the work now. Now, just some things that you're going to need to know when we're solving a variable of linear equations with 3 variables. Okay. All right. So that's the kind of the hardest part. Once you get the A, B, and C, you just plug them in that equation, that quadratic form, and you're good to go. Okay. So solve a system of linear equations with 3 variables. Just to kind of reminder. Number 1, we're going to have to decide which variable we want to eliminate. Okay. Usually, I think you'd want to go with C just because it's easier. You're going to work with a pair of equations to eliminate that chosen variable. And then, kind of use elimination, multiply one or both equations so that the coefficient can be opposites, and you add them, and that eliminates one variable. Okay, then you're going to have to repeat with two more. That's not necessarily on here, so I'm just going to add it to it. Okay, step 5, repeat with two other equations. Okay, it's almost easier to see when we do an example of that, but that's what we want to do, because then you can solve for one of the other variables, and eventually you'll get all three, A, B, and C, and then you can plug them in here. They kind of just skipped that step when they went right here, so we have to actually do it and work through it. So let's do this practice. Find the quadratic model for this sequence, -14, 3, -14, -8, 0, 10, all that sequence right here. Okay, so let's just get some information here. Remember, our quadratic would be modeled in this form. A sub n equals an squared plus bn plus c. So we're looking again, we're going to have to try to find these two values and plug them back into this form. That would be our equation. Okay, so when we do that, right now I can, for a sub 1, I'm just going to plug in -14 is the first term, and that's going to equal that's the first term squared plus b times n is 1 in this case, and then c, where the next term, so that would be, a sub 1, here's a2, would be -8. So we would have a 2 squared, and you can probably jump right to it, b to the 2 plus c. And our third term, we've got 0 equals a. That's the third term, so I'm going to put 3 here plus 3b plus c. Now, you probably don't even have to do this part right here. Once you get rolling, you can kind of jump to the next step and go ahead and do that. But I just wanted to show you just like the example above. So let's go ahead and simplify these equations, okay? So if I simplify this one here, you're going to end up with -14 equals, well, it's going to come out to a, right? A plus b plus c, because, right, 1 squared is going to be 1 times a is a, and then b times 1 is b, and then c is left there. Okay, how about the next one? -8. Well, now I've got 2 squared, which is 4, so it's going to be 4a plus 2b plus c. And then the last one, I've got 0. 3 squared is 9, so it's going to be 9a. 3 times b is 3b plus c. Okay, so now I've got a system of 3 equations. So here's where we have to kind of use these rules right here and say, how am I going to do this? Solve a system of equations with 3 variables. So the first thing is to pick out a variable that we want to eliminate. To me, C is the easiest because I just had to multiply one of them, one equation by -1, and I can get those to be opposite. But I got to pick 2 equations that I want to work with to do that, okay? So let's say that we just pick these 2 equations here, right? So I pick those 2 equations and I say, you know what? I'm going to work with those to eliminate C. That's my goal, right? So if I take this equation here and I multiply it all by -1, I'm just going to do the work over here. Then that's going to give me 8 equals, because you got to multiply everything by it, right? So 8 equals 4a, actually be -4a, right? Minus 2b minus c. And then this one we keep the same, so it would be 0, just going to do that, equals 9a plus 3b plus c. So now you can see we have opposite c values. So now when we go to use addition, those are going to cancel out, and I'm going to be left with 8 equals 5a plus b. Okay, so I'm going to leave that there for right now because I'm going to use that later on. Okay, so I'm just going to kind of put a little circle around it that I can use that when I try to find out the rest of the variables. So now I'm going to do the same thing because I've eliminated that variable. We're all good. And so now I'm going to do the same thing, but let's do it in green with the first two equations. Okay, so I'm just going to try to eliminate C again. Why not? And I might as well just keep this the same and just multiply by -1 with that second equation again, because that'll eliminate C for me. Okay, so in this case, I'm going to keep the first equation the same. -14 equals A plus B plus C. And then again, I'm changing the second equation, which is basically going to be this one. I've already done that work, so I might as well not, make it harder on me. So I'm going to go 8 equals -4A, -2B minus C. Okay, so again, all I did was multiply the second equation by -1. So now when I use elimination and add these up, the C is going to be gone, and I'm going to be left with -6 here when I add. This is going to be -3A, and then -B right here. Okay, so again, now I'm going to use these two. Now that I've eliminated C, now I have two equations that I can work with to eliminate either A or B in this case. So let's write those, the two that I boxed up in red. And I know this sucks. It takes a lot of work, but you're doing it 3 different times. I know it's not the most fun, but hey, it is what it is. So I take this first one right here, 8 equals 5A plus B. I'm going to take the second one right here, -6 equals -3A minus B. And now I'm going to work to eliminate those. Well, it looks like it's already set up. It's nicely set up for us because the B, I have a positive and I have a negative here. So those will eliminate right away. So then I'm going to end up with 2 here equals 2A. And so now I can solve for A right now. A equals 1. Okay, so that's good. All right, so I know that A equals 1. Now I can go back and use one of these original equations right here. 8 equals 5A plus B. If I do that and say, all right, 8 equals 5 times 1, right? Because I know A is 1, plus B, I can find B equal to 3 here by just subtracting that 5. So now I've been able to solve for 2 of them, 1 and 3 for A and B. Finally, I got to find C, right? So I know right now I can go back. I'm going to use the original equation because it's pretty simple. A, B, and C all equal to -14. So I can solve that really easy. This is 1, I know that. B is 3, so it's a total of 4. So how do I get to -14? C has to be -18 in this case. So now I know what all 3 variables are. So now I can go back and I can write them in this form with my new A, B, and C. I know A is 1, I know B is 3, and I know C is -18. So I can rewrite my answer here as follows. A sub n equals n squared because A was 1, plus 3n because B was 3, minus 18 because C was -18. I know it took a lot of work to get there. Hey, deal with it. All right, next up, let's move on to the next page here. So when we talk about sums of finite arithmetic sequences, the next thing we got to discuss is we've got 2 different formulas. So whether it's a series with n terms or with a partial term. So we can do n terms or partial. Then we can use one of these 2 formulas here to find the sum of it. Okay, just for some tips here as we go through it, then we'll do the examples and go. But some tips here would be, if using formula 1, then it's going to be important to find n. How many terms are in the sequence? Sometimes we can substitute values into this equation to find out what our n is. Then we can go to work with formula 1. If the nth term is unknown, if we don't know what that term is, we can use formula 2. All right, so let's do an example of these. So for this one, find the indicated sum. So in this case here, we're going to use formula 1 in this one. So we'll use form 1 here, just so we know. All right, so again, I got to find my A value. So I got to substitute some values into this equation to get my or not my A value, my N value. That's what I'm looking to find. Okay, so I can find some different things. I know that the nth term here is negative 455, so I can plug that there. I know my first term is 211, so I can plug that in there. I don't know what N is. That's what I'm trying to find. And my D value, I can find, remember, by the sequence, right? What's subtracting here, I end up getting negative 18. All right, get that difference. That D value is the difference between each successive term. It's a negative 18. So now it's just doing some algebra here. Negative 455 is equal to 211. This is going to be minus 18n plus 18 once we distribute. And then I'm going to keep going here. I believe we get 674. Let's see. Yes, you do. You end up combining like terms and subtracting. You're going to get negative 674 equals negative 18n. Just doing algebra, and n is going to be equal to 38 here. Okay, so that's key. Now I can go ahead and use Formula 1 here from up here. If I use Formula 1 right there, that's what I'm going to try to do. Okay, so S of n, so S of 38 terms there would be n over 2, so 38 over 2 times a1 plus an. Well, a1 I know is 211, and then an is negative 455. So I can do this math here, do the parentheses first, and then multiply by 38 over 2, and you end up getting negative 436. Sorry, should have wrote that better. So the sum of those 38 terms would be negative 4,636. Okay? All right. Now, let's go to 6b. Now, this one, we're going to use Formula 2, okay? Because we don't know the ... here. We don't know the last term. So in this case, we can jump right to the formula. We can say S of n is n over 2 times 2a1 plus n minus 1 times d, okay? So let's find out all that information. We know that it's 19th term is what we're looking at, so S of 19. So that's going to put 19 for my n value. That's going to be my n value. So 19 over 2. Then it's going to be 2 times my first term. Well, my first term is right here. That's a1, negative 19. Okay, plus n minus 1. Again, I know that n is here, 19th. So 19 minus 1 times d. Well, I have to look at the successive terms here to find d is going to be 42. So then I can multiply here. Now it's just doing the work in the parentheses. So I'm going to get 19 over 2. And I'm going to take care of this bracket first, negative 38. And then I have 18 times 42 here. And then you can kind of do the work. I think you get 19 over 2 times what's going to come out to about 718, I believe. And then that's going to give us a final answer of 6,821 for S19. Okay, so kind of using both formulas there. All right, moving on. Looking at these. So now these are in sigma notation with the sums. So nothing too crazy here. You can still use your formulas that you're given. But something to think of is to find n here, we're going to use a different formula to find our n by saying, all right, you're going to take the first term, which is here, 23, and you're just going to subtract it from the upper bound. Your n value is going to be the upper bound, 37, subtracting the lower bound, 23, plus 1. That's going to be your formula to find n. So in that case, I know here that n is 15. Now I got to find a couple other things so I can use the formula. Remember, we're going to need a1, and then I would be in good shape to go. So if I find a1 here, I'm just going to plug in my first term, 23, in there. So a1 would be 2 times 23 plus 3, which is going to be 49. So I already have n equals 15. I've got a1 is 49. And then I just got to think about what an is. An is now, the nth term is 37. So I'm going to go 2 times 37 plus 3, which gives me 77. So now I've got enough work to do the formula because now I can go ahead and use Formula 1. Okay, Formula 1, remember, is n over 2. The sum of n equals n over 2 times a1 plus an. Well, I've got all those. I've got my an here. I've got my a1 here. I've got my n. So I just had to figure out some work first, and then I can go ahead and plug it in, s of n. In this case, we're talking about the 15th term because n is 15. So I'm going to go s of 15 equals 15 over 2 times 49 is my a1, 77 is my a sub n, and away I go. The sum of those 15 terms would be 945 when I do that math. Okay? All right, same thing here on another sigma notation one, okay? Again, let's find n first. N is going to be my upper bound, 18, minus the lower bound, 12, plus 1. So my n here is going to be 7. Okay, that's what I needed. Then to find a1, I'm just going to plug my first term in here. So negative 2 times 12 plus 57 is going to give me, what's it, negative 24 plus 57 is a1 is going to be 33. Okay, so good. And then a sub n is going to be this term here, 18. I plug in here, negative 2 times 18 plus 57. So then a sub n is going to be 21. So now I have all the stuff I need. We're talking about S7th, because that's the n term, is going to be 7 over 2 times 33 plus 21. We've got all those right there. And so S of those 7 terms would be 189. So easy ways to find sums of those sequences. All right, how'd we do time-wise? Okay, not good, 22. That's okay, better. This could have been a lot longer. Put in your questions, go back and rewatch if you need to. We'll see you next time.